Okay, today we're going to talk about addition vectors, and displacement vectors. So high level, chapter 3, section H. So a vector is something that has movement from one point to another. So this orange line here is a vector. Vectors have magnitude, which is the length of the vector, and they've got direction. Okay, so it goes over 3, up 5, right? So I could write this like this, starting at point A, going to point B. You can write it with a lowercase for array, or you could write it with a lowercase to represent the line with a single arrow to represent that it's array. Okay, so in component form, I could write it as in the x direction I go over 3, in the y direction I go up 5. I can write it like this. If I'm going to write it in base vector form, the x value is always written with a y, and the y value is always written with a j. So that's written in a base vector form. Okay. Now, if I wanted to go from B to A, it's the same thing, but the opposite direction, right? I go down 5 and to the left 3. So I'd say in the x direction I'm going left 3, and in the y direction I'm going down 5. So basically, if I wanted to have AB, but I knew BA, you could just multiply it by a negative value. Okay, adding vectors is really simple. You add the x values together, you add the y values together. Okay. Another thing is a scalar is a number that you multiply by a vector. And a scalar changes the length of the vector, but not the direction. So if I wanted this orange vector to be 3 times as long, then I would multiply this vector 3, 5 times. If I wanted it 3 times as long, I would multiply the x value and the y value times 3. So like in this example, if I wanted AB 4 times longer, I'd multiply 4 times the 3 and 4 times the 5, and that is my new vector multiplied by a scalar of 4. Okay, next. Position vectors. Okay, so the first thing I'm going to talk about is parallel vectors. So parallel means the vectors go in the same direction. They might have if they're in the same direction, they might not necessarily have the same length. For example, this vector and this vector have the same direction, but B is much longer than A, right? So vector A and vector B are parallel only if B is simply multiplied by a scalar. Okay, so like we just did in the previous example, we multiplied it by a scalar. Okay, now scalars, as I said before, they change the length, but not the direction. Okay, position vectors. Position vectors are when you've got a point and the displacement is from the origin. So in this example here, I know the coordinates of A here is 4, 0, right? No. 4, 2. Oops. Okay, 4, 2. And so if I'm going from here to here, I'm going to the right 4, and if I'm going from here to here, I'm going up 2. And to go from the origin to B, I'm going to the left 2 and up 3. Okay, now what if I wanted to go from A to B? A to B is this orange line, right? So basically I could say, well, I could go from A to the origin and the origin to B, right? And that would give me the orange line, right? So if If I go from A to O, I'm going to have AO. And if I go from O to B, I'm going to have OB. Now, we don't know, well, we know that OB, we just said it's right there, right? Negative 2, 3. But I know that O to A is 4, 2. And on the previous page, we learned that I can switch this by simply multiplying it by negative 1. And now I've got O to A if I switch the signs of those values here. So now I've got, let's plug in the values, 4, 2 for OA, negative 2, 3 for OB. Okay, since I've got the scalar of negative 1 times this vector, I'm going to have negative 4, negative 2. Okay, and then so negative 4 plus negative 2 is going to give me negative 6, and negative 2 plus 3 is going to give me 1. And that's what you need to know to do your first two sections of H3H and H3I.